so many people who are interested because, like we said in the last two, this is going to be the future. And I would like to start the proceedings. I was caught up in traffic for, I guess, around 15-20 minutes just on this bridge, the overhead bridge. And I think we seriously need AI because I planned 1 hour to come here. Something should have told me, look, 1 hour is not enough, at the current traffic rate, these are time that you should take 1.5 hours or something. So we seriously need to look at AI. And it's my great pleasure to invite, we have two great speakers today. Dr. Ruan Veerasinghe, currently the Dean at IIT and formerly the Director of UCSC. A colleague that I have known since I started my career, and I don't think he is in the AI area, but is a person that I really respect and admire for his thinking, let's say, out of the box. It's a niche word, but the moment you say out of the box, people start asking which box, okay. Out of which box. So anyway, I've seen him thinking, I've seen him working. So it's my greatest pleasure to introduce him. And then we have another speaker, Mr. Roshan Anushkapiris from again Zone 24/7, a software architect at Zone 24/7, currently working on many AI-related projects in natural language processing, big data, and machine learning. And after these two speeches, we'll invite another panelist to join us, Mr. Janaka Pitadenia, who is an associate director at Virtusa, currently working on projects related to machine learning. So I'm sure that we'll have a great afternoon. Without further ado, I would like to invite Dr. Ruan to take the podium and enlighten us on cutting edge AI technology, what is happening.
Thanks, okay, so the organizers have done a very risky thing. They can speak on anything, and that's like a blank check. So today I want to talk about politics. Someday I will do that, yes, politics and AI, but I wasn't so adventurous. I think I must confess I stole this phrase from a book because now and then is a way in English of saying very rare. Very rare. Now and then, how often do you all meet? Now and then means very rare. But it's the opposite of that. Natural language processing is, by the way, not neuro-linguistic programming. If you search on NLP, I think there are as many or probably more on neuro-linguistic programming because people are, all keyed up in mysticism and all these things that you can achieve beyond your abilities. But this is really natural language processing, and I just thought I'll talk about then and now, but it didn't quite work. Natural NLP then and now doesn't go. NLP now goes. So first, I'm going to talk about the then because I think a substantial amount of my research life was dedicated to the then. So the then is kind of most well signified by this tree. Everybody thinks when you do NLP, you have to have a tree like this. Otherwise, it is not NLP. And the major questions were, humans discovered was that we should ask people and ask, how is it that you process language? And in fact, we do this also in medicine. We ask doctors, how do you diagnose saying that somebody has dengue instead of, this is just a viral fever? And they try to explain, and humans are very bad at explaining how they think. So you can say things like, because there was fever, but not high fever, and so on and so forth. And then we put them into rules, and it fails. So it turns out that apart from what he tells you, he knows a bit about his family history. He knows that somebody down your lane got dengue, and so much of other things. It's called tacit knowledge. A lot of things that he doesn't say, he processes when he makes that diagnosis. And same thing with language processing. So we can't really explain how we process language, except that if someone makes a mistake, we know there's a mistake. Even in your own language, Sinhala or Tamil, somebody makes a mistake, you know there's a mistake. But can you explain to him why it is a mistake? Pretty hard. You can correct him and give the correct version, but very hard to say why what he said was wrong. The second thing is, of course, we thought, who knows about how humans, so we asked humans themselves, and it's not so good. So let's ask the next group of people who know about this. There is a linguist. So we asked the linguist. And they told us, the way we process, and we really like it because we are also people who divide and conquer big problems. So they told us something like this. First, there is phonetics. And so you get the sound signal. And I think we have all used this kind of software and, for the first time, seen our voices. We can't see our voices. This is the way to see your voice. Turns out that with that kind of thing, you can't really, you don't know enough about the signal. So you need the kind of signal at the bottom called a spectrogram. And even the spectrogram you can see is pretty messy. And if you think about it, whatever I'm saying doesn't have spaces between words. If it had, I would say, doesn't have spaces between words. That's the way I would speak. We think that we are putting spaces, but actually it's a continuous signal. And so it's breaking that up into the correct way is the challenge of speech recognition. But that's not enough, because we need also some linguistic representation of that. So it's not just the physics of the sound waves we produce. It's a fascinating thing to learn. This diagram is there. It's a very famous website now, which is an app. I forget the name of the app, but it shows all the organs, or the parts of the organs that we use in our vocal tract, and how participate in making human speech. Incidentally, sounds that still we can't modify. unfortunately. Otherwise, it's doing really nice. If you can modify the speech, then you can do a lot of stuff. Things. So, why have I written that phonetics in a funny way? Because that's using IPA, the International Phonetic Alphabet. We Sri Lankans, we are very proud. We say, not like these English and all these other languages. We can write in our language perfect spelling, perfect. So if some guy comes and says he's Michael, in English when you spell that Michael, you don't know whether it's Mikhail or, in fact in some countries it's Mikhail. But we can say, okay, if Russia is normally Mikhail, so we can write Mikhail in Sinhala. In Tamil, bit more challenge. Oh, Michael, that also we can write. So we are very proud. We can write anything, but turns out it's wrong. We can't. I'll give an example in the next slide. But the IPA is used exactly for that. One hand is used to write any sound, and on the right hand side there, what do you think that is? You don't have that kind of sound. Can you read that? Can you read that? The physics. And yeah. The physics of, the physics and yeah. So that's hard, biology. Of last one is sound, speech sound. And the difference between these two is the top one is how British state and the bottom one is how American state. So it will be really interesting to see whether we can translate how Sri Lankan say. Yeah, I mean, this is not the way we say it because that is like, we can't pronounce it that way. The two arms, can you see that? So if they're small. So you can how difficult it would be to put something like this in rules. And yet we now use, I don't know, Siri or Google or whatever, and we just so most of my students come and say, I say, now how are you going to do that? No, you just call the API. And behind the API, there's so much of work that is done. So phonology is about the linguistic side of phonetics. So phonetics is the physics, and how we make these sounds in our vocal tract, and then how it travels through sound and data. Phonology is about the linguistics of those sounds. So this is actually what is called the vowel quadrilateral. It is so up here we have up, and up there E, behind U, and back here O, and that shape is depends where our tongue is. At this point, I can normally look at what it is. Good if you do that. But then, so we have it doesn't have a. So, but can you see the number of other vowels? So I met a person from Cambodia or Laos, and he said how many vowels? So what are the vowels? So I said, and British person was like, oh my God, saying the same thing. And I asked the other guy, and that guy said, it was like one continuous thing. He had like some huge number of vowels. So it turns out that we also have some vowels that are OD and F. This is the first example. No? Those two words are pronounced differently. Otherwise, it will be mama or mama. So the second one is pronounced with a. How do you write a in single? Can you write a? You can't propose. So we propose that we invent a character for a. So that like that's why we can't write earnest. We can't write certain sounds into it. So the general rule is only the last one gets the sorry, only the first one gets the R. So this you say ha and then the and the. But of course, every rule in linguistics has an exception. So, though this is called hara, if you do something, verb, do something and then do something. So every rule has an exception. Same, it's the normal rule. But, well, so you see that. Okay, there's a nice. So this second sound is actually in the middle here. It's the least, and it's called the schwa, least energy vowel, and that has something to do with why we have that sound. It's so easy to make that sound. So we have, I think, 54 letters, and in Tamil there are some 40 something. In English we say 26, and so on. But most languages, amazingly, have roughly around how many do you think? Alphabet of sounds. Around 40 sounds. So which means we should be able to make all kinds of words, those 40 sounds. And of course, there are a lot of sounds speech sounds that we can't make. For instance, the Dutch have like a guttural. It is kind of so it's we can't control those parts. Yes, we can't. So this here becomes cur. Cur is this, but this area we don't have very good control of. And then there are some interesting things like what is the difference between per and burr. Per and burr. If you look at my lips, per, burr. No difference. But if you can take a, not extra, and see this cross section. The only difference is still on together. Only difference there's a little thing here that keeps vibrating. So one is voiced, the other one is unvoiced. Per is voiced, burr is voiced. And difference between sir and don't have sir. Okay, I'm getting carried away a bit, so let me just move on. Then they say, after that, those sounds you put them together and you get a word. But the problem is that words have many parts. So all these endings are called suffixes. There are some prefixes, and so she's trying to use a lot of prefixes in order to try to figure out what is the opposite of obvious. Turns out that there is no logic in that, but actually there is a logic in the phonetics. So if it is practical, or if it is let me say, yeah, if it is practical, we say impractical. Okay, but if it is immortal, we say immortal. If it is reversible, we don't say irreversible, say irreversible. So that's because it's difficult to say irreversible. So generally phonetics decides what those prefixes are. Here, in English there are very few of these. So I wanted to just get an appreciation of what happens when you come to an agglutinative language like Sinhala or Tamil. This is one stem, one root, and this is the challenge we have in Sinhala and Tamil speech. Sorry, not speech, words. If we want to put it in a dictionary, can you imagine the size of the dictionary? Because this is just one verb, one stem. So for all the verbs, we'll have to have lots and lots of forms. Next, they say, once we know the word forms, so what's the point of having word forms if we don't have word forms, morphology? Each of these in the computer is a different word. If you index a different index, unless we capture the stem and suffix and prefix, we will not be able to process this properly. Then they say, okay, now you have the words, word forms and everything. So now you have that nice tree. To do that tree, to get that tree, I have to normally have a grammar and be able to write something that will scan or parse my sentence and build this tree. Turns out that that is for ambiguous sentences, we know there will be 2 or 3 trees, but it turns out that if you're only looking at the form, focused on the form and not on the meaning, if you're only looking at the form, even a sentence of 10 words, you will easily run into thousands of these partial parse trees. And that's the really messy part, because we can't do it deal only with form or only with meaning. And then they say, okay, so these are examples of grammar like that, a very famous grammar. These are all the terminal and non-terminal, and that's this Chinese sentence parsed using this kind of a grammar. Then, of course, we still have got very little because we only know the form, structure of the sentence, but we really are interested in the meaning. And meaning, for word to meaning is semantics. And I'm sorry, this diagram is not very good. It looks still like a parse tree, but it shows what is called compositional semantics. That means if I can have a meaning embedded in each of these terminal symbols, which are actually words. Terminal symbols. Those are words. Luckily, there are no linguists here. Unless you say terminal symbols, they will not know what that is. But these words, if we can encode a lexicon, a dictionary, semantics, when these two get together, we will get a lambda expression that builds up finally to a logical sentence, a logical statement. Usually first order predicate logic. That's what we use for this kind of thing. Then it doesn't stop there, unfortunately, because we don't just speak sentences, unrelated sentences. Almost every sentence we speak is related to the previous one. Yeah. So can you see this? So the it. What is the it? And then the other one, should. What is the should? Really, and so on. He, she, they. And when you say, if I can say, if I say, I hope you like my presentation, and that it was not too long, it, and you can go back and see what is the last inanimate thing he referred to. But if I say it is raining, what is raining? English is very strange that there are some uses of these pronouns that are really mysterious. So discourse is trying to figure out in either a monologue, in a paragraph, how things relate to one another, or in a dialogue. That's even more frightening. People speak from their point of view, a dialogue, or the multi-party. Routine, we do these things and we don't even think about it. But when it comes to over the net, we get a few of these problems. It's a really complex thing that when you're face to face, it's effortless. But online, mostly we mess it up. Two people start talking, and so when we're looking at the body language and tone and so many things that this person is finishing. Now it's my turn. Very complex way of turn taking. And then that doesn't finish there. This is the last one. And this is, what this thing, whatever you said, means in real life. What it means in real life. Pragmatics. So pragmatics. What it means in real life. So if I tell you, can you close the door? You can very well sit here and answer that question. Say yes. And not do anything. No? Because that's a very correct answer, because you can. But the meaning of that sentence is not whether you are able to. It is asking him to do something. So where language is grounded is where pragmatic comes. So that's one example. There are lots of places where is grounded. So if I say Cameron said something in a sentence, so you can analyze that. Cameron most probably is a proper noun, so said something. That's all. But grounded, you have no Cameron. This Cameron is the British Prime Minister. Was. To relate it to real world entities, and that's the area of pragmatics. So after all that, oh my gosh, people are really tired. We have to do all this to process language. So the second part of my talk is the now. Then we did this. Now what do we do? Some bright folks came and said, we don't have to ask the linguist. We just look at text. Corpus is the word body in Latin, but we are talking about body of text. You just look at the body of text. Bergelinet famously told his that we are extracting patterns by looking at text. In this particular case, not text, but sound. And we drop the requirement that it has to be done the way humans do it. That is optional. So if you are doing machine translation, you suddenly say, earlier machine translation meant you do that whole thing and come up to the pragmatics and then map to another language and generate. Now you will say understanding is totally optional for machine translation. Understanding is optional. And if you know the Sir John Searle's Chinese room argument, where he said that you can process something without understanding. Actually, he was talking about what we are doing now. Now we are processing without understanding because we just see a lot of, say, Sinhala coming this way and a lot of Tamil going out that way. If you watch that for long enough, you can become a translator. In fact, I can give you two completely unknown languages with enough repeated words, and I give you half an hour. You should be able to translate some of those at least. So you can imagine it's just 2 pages. So now we need millions of words. So that dropping those requirements of doing it the way humans do it and doing it according to the way the experts say it is done, and looking at text and looking at speech free from a lot of earlier held beliefs. So this is probably, I think this was 50s or something. Yeah, first he said, "You shall know the world by the company it keeps." Single saying is probably the most quoted thing about language in any modern application. So this is, you want to understand the meaning of the word ubiquitous. Number one, you can look in the dictionary. I think you won't understand. Second one, you can get a thing like this and search for the word. And you read all the uses of ubiquitous. And you can use it in your next talk, like I just did. But if you take table, you can say it's mounted on 2 or more legs or something. And an alien will not get anything out of that. But if you say, I eat at my study at my table, I put water bottles on the table, and so on and so forth, they will get the idea. So that's the basic idea that people used for most of the processing we do. So we went back to the drawing board. Let's do. But what is the aim of language model has been to draw that syntax tree. You say no, you don't have to do that. Or some people think the aim of language model is do a grammar. No, you don't have to do it. All they have to do is always not to something grammatical or ungrammatical. Something is grammatical. Because even with ungrammatical sentences, we can, I mean, when you talk to Chinese or Japanese or something, we manage. I go, you come, huh? And then after some time, you also talk that. But we can manage. You don't have to have it. But in the whole system, if the systems are brittle means it doesn't pass, then the output is not, no output. The syntax tree can't be drawn, so it fails. Exception, no whatever. What we want to know is probability of the tallest person in the room should be much greater than the tallest the person in the room, and that should be much greater than tallest the person in room. If we can have a model like that, then we are set. And model for that is absolutely simple. You just count how many times one word was followed by another, divide it by this word. Estimate word one given the previous word. Very simple idea, and you can generalize it to n words. Just count. All you do is count. These are called maximal likelihood estimates. Just count, and then there's a nice little thing here. The probability of a sentence. Conventional statisticians will say the only way to get a probability of sentence is to see how many times, how many sentences ever spoken. Out of those, how many times was this sentence spoken? Not practical. That's not practical. So instead of the probability of a sentence, we estimate the probability of sentence by the product of the probability of these engrams. Shorter bits. Shorter bits we have seen. We see lots and lots of examples of shorter bits. And when people try this, voila, suddenly you started getting really good language models. And today nobody creates language models except this way. I mean, I'm exaggerating a bit, but that's my vision. And then, most of the tasks of NLP became classification, supervised learning tasks. Some of the others may talk more about, but so part of speech, I didn't really talk about part of speech. Like means you try to figure out whether this is noun or whatever, because it's not clear from a sentence. So table can be a noun or a verb. I can table minutes at a meeting or something. So in English, it's really bad. Exercise for you. Think about in Tamil and singular. Where is the complexity? In English, almost every word has more than one out of speech. The common word. Share. Solidarity. What is this sharing with me? So basically, if you have somebody laboriously sits and says these are noun verb sentences, then you can extract from that only one step higher than the n-gram model that we can call a model. Very nice, very nice. It has the same kind of transitions. Only thing the transitions are between some hidden states which are the part of speech tags. And we are getting really good performance in guessing parts of speech of any text. Name entity and extraction similar. So you have lots of text and you say this is a name, this is a name, this is a name. And then you get learn from that. Mostly, so the first ones are all sequence based. H&M, Maxim, CRF and so on, they look at, they value the fact that these are in a sequence. Other things are text, a bag of words for this. They don't care the order. You just need to know how many of these words, how many of these words in this sentence or in this paragraph. And we have lots of algorithms. I mean, if you go to Weka or Scikit-learn, you have a whole lot of algorithms you can throw at these things. Event extraction, and of course, the really sexy thing now is sentiment extraction. From not from the University Grants Commission, but in the generated. So everybody is doing user analytics. Incidentally, anybody on this? I don't know why it's offline all the time. On the US election, to see sentiment of the people, and you can see these things changing weekly, sometimes daily, based on what they say, what these people say. I still remember, I think, when we were in UK, they said every time the Chancellor of the Exchequer spoke, I mean, that's the finance minister. Every time he spoke, the pound went down. So they had to make him stop speaking. So, like that, you can see how these sentiments vary when these people make pronouncements. Yes, more data, better data. The two mantras, no? More data is better data. That's like really. So, when we started doing some work with single English, we got really good people to come and translate. You got to create your parallel course. And these are people who can translate. But then Google came and asked, can you give us stuff? And we said, it's really hard to do. And there are so much. How many? And then we had like, I don't know, 2,000. And they said, no, they need so many millions or whatever. Okay, they went. I don't know, some of you may have. They crowdsourced it, but not free, with money. So a student came here in the 1.5 lakhs last 2 months. Just translating. Now he was not a translator, he was just a normal student. Our people were really good translators. But the problem is, more data is better. So one person makes some, another person another way, somehow, like magic, they get cancelled. And you get, but you have now today Google, the single English, very decent, very decent. We don't think, but that's because they're pivoting to English. They're still in the game. More data means better algorithm. That really infuriates machine learning. They're building these new algorithms, and when you say more data means better algorithms, they get really offended. But that's why Google can just put the TensorFlow and just watch you struggle, because they have the data. You don't have that kind of data. The volumes that they have, you don't have. Their speech recognition is very good. Dragon, which was like the leading, Dragon has been in this for decades. But they are translated. If you go and say, if you want to get an American accent, really go and use that. Because you have to speak like an American in order for that to recognize. But now with Google and because they have zillions of speech samples, so they can recognize our accent. And now, these days, they are doing a text-to-speech. Unfortunately, they do an hours. And we tried hard to zoom in from some more to people, and then they go in. Because they have so much data. Very good. Text model, it is instead of more, probably we cross-validate so that we don't waste any data. And very few problems in language processing have been completely unsupervised. Yeah, I'm going to see this, but so everything has a probabilistic equivalent, and when you say probability, all these figures, these are like this, and all these can be extracted from text that has been manually passed by someone, and that's why we don't have any for single, unfortunately. Even for English, there is a thing called entry bank, I think I could tell you. People have manually gone and passed big corpora, and you can extract probabilities of these rules and probabilities of the lexicon, and you can create this kind of a chart to propagate these probabilities to figure out what is the best, highest scoring sentence. But then we got stuck there. So we have a nice parse and everything, or we have a nice language model, we have a nice parser, we have everything. But beyond that was a challenge, semantics, meaning. How do you figure out the meaning of something? Until a few years ago, somebody came and did a very simple thing. IRT, information retrieval. They wanted, if you have lots of documents like this, and document A has Nova 10 times, Galaxy 6, 5 times, and so on. B has it like this, C, D, and then suddenly they just counting. That's all, only counting, and then suddenly they realize, hey, I can say from this A and B are very similar. C and D are very similar. E and F are very similar. G is on its own. And yeah, the other three are kind of on their own. So you can figure out just by this signature, if you like. Signature, you can figure out document similarity. That was neat, but well, and that's the basis of today's topic models. But what was more interesting was word embedding. So you do the same thing. Instead of getting documents and terms, you get terms and terms. The term matrix. So human interface computer, blah, blah. They are also human interface computer, like that. And you try to figure out how many times does response come with human. Obviously, 0 here, and then some other numbers. X's means with themselves. So human. Turns out that this gives a signature for the word. Survey. What's the meaning of survey? That's the meaning of survey. Linguists. No linguists here. Linguists will kill you if you say this is the meaning of system. But it turns out that, in fact, when they first did this and they thought of this ingredient business, they found that, this one shows like the, but let's say cat was here and dog was here near the computer. So this is like cat and dog and computer are similar. Until somebody realized, okay, that's not the way you do listen, not Euclidean, you do cosine distance. So even though cat and dog are like that, they are on the same cosine angle. So if you use cosine similarity, then suddenly we see that this is called residual resonance. It is able to distinguish between different words, and that becomes then suddenly a basis on which you can start doing. Today it's called word embedding. And so we threw some neural networks into this. and are able to get relationships like this. King is to queen, man is to and so on. I think I've taken. I will very quickly try to go through the rest of it. Okay. So the return of the, a lot of people wonder why what is deep learning, but the fundamental problem was that we had the neural net model, and in general we said you can have any number of hidden nodes and any number of hidden layers. And in neural network book you will see that. Problem was we can't calculate that because the the way the neural net trains itself is by adjusting those weights, but there is a thing problem called the vanishing gradient problem when you have so many layers. So for a long time, people just didn't know what to do until people came out and said, okay, we have some, today we have, what do I call the RNN, CNNs and things that allow us to train multiple layer models. Deep learning is nice. It's actually neural network. Yes. And so speech recognition has shown error rates of 25-30% for like 2 decades. Unfortunately, the Red Jelinek died in the meantime, but in one of his last conferences, he said, you guys who are doing translation, you all have taken this really far in the last 10 years. But we have stayed 3 years in speech. We have stayed stagnant for 25 years. But soon after he died, so 25 years and all the 25% phone error rate is not word error rate. It is phone. So this is still pretty good. But you can see the last 3 years, all these technologies are based on multiple hidden layers, all kinds of terminology. But and so now people are suddenly, of course, when this happens, everybody thinks this is the cure for all and apply this to everything. Right? There is a Stanford NLP group. They are trying to do deep learning into everything. I'm a bit skeptical, but because when I say lower end, that is the wrong idea, but things where you have a lot of information. Because these deep learning models actually, they gobble up data, they need a lot of data. So that's why instead of those days, I'll talk about that. So here's a thing that used. So the thing that we have a lot of examples are characters. Words, we don't have many. Even if you have 10 million words, that's not very much. 10 million words means characters, 50 million or something. So this may not sound very nice, this sentence, and may not make much sense. What is impressive is that this RNN knows only characters. Only characters. You can see this by, so it doesn't know that this is E followed by some letter followed by, but actually generative model, that's why you can generative model as opposed to a discriminative model, you can't do this. So, and of course this is with a small corpus of data. And since more data is better data, very soon if you train the Shakespeare's work, They are building other more glamour. And then and and this is going to continue because we are in this information overload world. Already we can't keep up. I don't know how do you keep up? So the way to do it is restriction. There's so much data we better put my head. That's the people don't read. I mean, I don't know. Anyway, we don't buy newspapers. We don't buy newspapers. No. Maybe, I don't know, some people's news may be the email, or the Facebook, something like that. But I actually, this was a big problem for me. Because suddenly somebody comes and says, do you know this? I don't know. So now what I do is, I don't search from Google or anything like that. I search, I know this guy is a really good journalist. This guy is a real good political analyst. That guy is a really good economist. I just follow them on Twitter. So you can't get a filter like that. You can't get a filter like that. So we continually have to do summarization. So summarizing documents, sentiments, opinions, personalities. One of my students did something with status updates, trying to figure out the personality of the person behind that. Using D5 model. And it's amazing what you can achieve. Of course, luckily we had label data, otherwise you don't know. You need label data at least to see whether your system is doing well. Even if it's not trained. Duplicate identification is a common problem now. Stack Overflow, how many questions, the same question asked. Earlier people used to go and write, this is a duplicate question. But you can't do that anymore because millions of questions. So you need to be able to do this kind of thing. News, you don't want redundant news. People are saying the same news. And then categorization of news. So you subscribe to something and then you are able to say these are the categories I want to read, nothing else. Categorization of documents. And now be interested in this. Data visualization is a kind of a well understood area. We have lots of things. We have gone beyond just the pie chart, the bar chart, and scatter plot, and we can do wonders with data. But with text, it's a bit harder. So I've used for this presentation all through only one visualization. What is that? The tag cloud. That's all I use. But there are many, many more ideas out there. In this collection, there are 290. Some of them are rotten, but still there are ideas how to. So we need more and more ways in which to see summaries of data. And of course, the Holy Grail, it keeps moving. The Holy Grail at one point was speech recognition, but we have kind of mastered that. Then it became machine translation, and Google messed it up for us because we don't have any way to get funds anymore. Question answering, a la Watson, still not easy, and if you go to do some of these things for our language, it's really, really hard. And then semantic learning. So it's one thing to build a system and then it's stagnant. It's another thing to keep on learning. NEL is a never-ending language learning. The system that just keeps on crawling the web and building these triplets, RCA triplets. And then you're supposed to be able to query them. Okay, so challenge is very little done for a local language, so a lot of stuff you can do. Attractiveness of data-driven technology allows us to piggyback on this stuff, so you don't really need to have linguists and all those people telling us. But at higher levels, we need crowdsourcing to build these kinds of words and things if you want to do anything else and have it. And common with any IT task. Starting between the simple and the complex is really, really hard. I don't know whether you have had this experience. Somebody, a client will come and say, "Can you do this at this feature?" You scratch your head and say, "It will take 2 weeks." Actually, 4 hours and you're done. You can do it, but you will say 2 weeks and put a bill also. But then the guy goes, "Oh, okay, 2 weeks. Okay, I need this feature." He's thinking now another 2 weeks. And then you look at that, it looks very similar to the other one. Turns out you need to employ 5 people for 2 years. But generally it's not apparent, it's not clear. And so Apex computing agency function to English single English translate. That is a bit like that. So I made a proposal, and in my proposal I said it can't be done. Not like that. I proved that it can't be done by explaining how these models are made. But somebody else found it. And of course, we didn't get the result as expected. Thank you.
Thank you, Rohan. And talking about information over there, I think he covered the entire track of NLP in 1 hour, and I hope that some of these young people will take it up, and we will have what we need, the local language translators, etc. That we will, and we will have a chance to talk to one in the panel discussion. Next, we have Roshana. Rasham. Anushka Pires, the language translator from Sol Pentecostal Software Architect, who will again will give us, one talks about language, and he will also give us a glimpse of, what is happening in the AI world, as we have been doing so far. Sorry. No,
Okay. Thank you very much first of all to 7AA to give this opportunity for us. And this presentation is kind of a special one, mainly because the person who is chairing this session is actually my Java teacher at university 15 years ago, and the previous speaker is again my AI teacher and also my first boss. Right? So I would like to dedicate this session to my teachers and maybe your teachers also. So today I'm kind of bringing a different speech. As Dr. Rohan mentioned before, we were not given any specific topic. So let's see whether I can relate this speech to AI. So the topic today is about smart retail platform. Because now I'm going to relate AI and its application in the specific industry. So for this, I will take retail industry. And this is kind of from the business side, right? Now, of course, you can, if you are interested in academics, or you can pick one specific area, and of course, you can go deep, right? Learn about everything, how these things happen, and so, which is very interesting. But unfortunately, I'm coming from a software engineering background, and my life is a little bit different. So daily I am dealing with business problems. So I have to pick, okay, what kind of solutions I can apply to solve these business issues. Right? So before I start my analysis, let me give you some context. So we are dealing with at John Telco, almost all the largest department stores in the US. Right? And in between these department stores, they have this steep competition. And they have doing it price cutting, sales, discounts, coupons, like you name it, everything they are doing. Right? But what they have realized is their profit margin is day by day going down. But one would expect, okay, if you are giving so the customer should be happy, right? But apparently it's the other way around. So you are giving the products at cheap rates, but still at the end of the day, your customers are not happy. Right? So they have been doing all this, market research, especially like in US. It's very like they have money, so they can hire pretty much like consulting firms, and they are very good at spending money as well. So they are doing all this market research, but three things. Right? So one is a lot of customers saying, okay, their experience is very boring. Like if you go into a department store, everybody is the same. You have aisles of products, right? Maybe nice lighting, but that's it. It's very boring. You cannot interact with, and also it's very difficult to find the products that you need. Like if you go there, like especially in the department stores, so it's a very large area, right? And for each brand, probably you will have a separate area. But if you want to buy let's say a trouser, right? It's not going to be an easy task. Like even if you look at their web experience, if you go to a website, the searching experience is not that great. Right? So I will come back again because there are some connection with the NLP there, but it's very boring. And also the return rate, because what will happen is if you are not getting what you need, right, the customers will return that product. I don't know, like in Sri Lanka, this is not that common, right? You are only given like maybe 7 days. Strictly the late and a lot of conditions as well. But in US, it's not that the case. If you are not like the product, of course you can return it. And what they are doing is, okay, then you have this refurbished product thing. So you are doing some price cut again and again try to sell it. Right? So effectively you are losing your margin. Right? So it's a very big issue. And also, like the customer retention is very low. Because now everybody is like fighting with prices. Okay, one shirt is available at some store for $10, and suddenly somebody else is putting an advertisement, okay, 10% discount. That customer goes to that store. Right? There is no loyalty. So what's happened was like now people have realized this thing, like the top tech said, and they want to like come up with a solution for this. So now, I mean, all this time they were thinking about this financial side, assuming, okay, if you give a cheap product, you will be able to get more customers. Right? But that didn't work. So what they are doing is, okay, call everybody, right? Business analysts, even for the engineering team, we were also involved in. Like, we need a different way of looking at this problem. So this is kind of a summarized way of like for those reports have a lot of jargon and all, but just imagine, right? Imagine a retail platform that can sense the customer and make sense of the needs, intent of the customer, and take an informed action to satisfy the customer. Right? So, what if a retail platform can do all those things? So that's a question, kind of. So basically, it involves like learning about the likes, dislikes, and the patterns of maybe buying and maybe viewing products. So that kind of stuff, and also if you are to present something, like maybe it can be an advertisement, it can be a recommendation. So you should know when, where, and what to present, and also when to assist and when not to. Like also, if you go for a, even in Sri Lanka, right? If you go for a shop, before even you like look at something, okay, somebody will come. Okay, sir, there's this nice, trouser brand. It's fitting for you, right? So you forget all your needs, and somehow if that person is like good in negotiations, you will end up buying that. And on the other hand, and let's say you go there and the price tag is not there, and you want some assistance, and nobody is near you, right? So those are the kind of bad experiences. I not in Sri Lanka, it's happening big time in the US and all, because these are lot of big department stores and very few are there to assist, right? So those are the issues. So, but if this retail platform can really sense the customer and identify their needs and their intent and take a action, a satisfying action. So hopefully you will end up with better relationship with the customer, and you will be able to transform a random customer into a fan. Right? You know fans, right? Cricket fans and not the the rotating fan. So I have carefully bolded few terms here. That is sense, make sense, and action. So, so I'm not a biological expert, but in the biology at least, like if some entity can sense and can make sense of that sensation and can make a action, take an action because of that, we can call it as maybe an organism. And in this case, now as I explained before, retail platform, I also like underlined it. It's not the kind of platform like we software engineers, Java platform, .NET platform. It's not that platform. It's about everything, right? Even the stores, the websites, mobile applications, everything that a customer can experience. That entire thing is this retail platform, right? That platform. So if you look at these different components, you have the stores, you have these websites, mobile sites, creative applications, and if you look at each and every one, can do this sensing and make sensing and take an action. Like each and every one will be an organism, right? And collectively, it will, now individually it might not have that level of, very high level of intelligence, maybe a limited intelligence, but collectively, it will be more intelligent. So that is where this idea of superorganisms comes into the picture. Like you take like ants, individually, okay, it's an organism, but when it comes to collecting foods, right, it's as a superorganism, same as bees. Right? individually it's an organism, but collectively they are kind of a new level of intelligence is there. Right? So there is the same thinking behind this also. So we are trying to align all our systems, the the touch points with the customer, so that we can provide this experience. Right? And this is not a science fiction. Like a few years back, we actually started building this. So, so the next 10 minutes, I'm quickly going through how we are giving this sensing capability and making sense capability and taking this different actions into this superorganism. Right? So let's start with sensing capability. So I have this word called omni-channel sensor. The omni-channel itself is a buzzword these days. Right? It's been used in all kinds of cases, but here I'm just trying to say like the different channels. It can be a website, it can be a mobile application, it can be a physical store. So different channels and needs with the customer in that environment. Yeah. So there are few things we can do. The first thing is like inventory and asset tracking, including the locations of it. And also there is this thing called user behavior tracking. Like those are like in technical terms. As in like a lot of software engineers are there. It's about it can be a tracking SDK and basically track everything the user is doing, clicking something and go through some process, viewing something, and so on. Right? And also this email promotion. I'm sure like most of you will receive this kind of email promotions. Fortunately, there is the security measures that by default the images are not shown. But if you by any chance like select show images, actually you have it. Everything about that particular context is tracked. And also social media. So whatever you publish in social media about a given topic, it can be analyzed by external parties. I think that's what Dr. One also mentioned. Like we are not involved in the US, sorry, in the UK political, but we can analyze at least what different people are talking about that particular topic. The same thing can be done here as well. Now, if I am a department store owner, I want to know what others are talking about our store. Right? So we can do that analysis. Can be Twitter analysis, can be Facebook or anything. You can look for certain hashtags and you can get some insight. So that information also it's a kind of sensing. Right? And also we have this kiosk and hardware devices, especially we will interact. I mean, the customers can interact with them. Basically, you can go there and press something, look at something, and that interaction also we can track with, right? So those are kind of sensors in this superorganism. So I will show you one such thing. Like this is a Zero. It's actually an autonomous robot. The top yellow ones are the first generation Xbox 360 Kinect devices. They are put in the kind of 45-degree angle just to the for efficiency. And the kind of box, white boxes are like RFID antennas to detect RFID tags. So, and it has a whole lot of sensors built onto this one, and the readers, and of course it has its own navigation system, like object. Sorry, there's a some obstacle, avoid that one, and automatically detect. Take the path, calculate the path, and go there. And this one is basically we have implemented, developed to real-time inventory tracking as well as map a certain physical store. Right? So I will quickly show you like, okay, the left-hand side is just we are testing the prototype in one of our rooms. Right? On the right-hand side, there is a kind of vision that robot will see. It's a point cloud basically. Now, if this robot can navigate through the the physical store, so it can basically construct this kind of point cloud. It knows what are the different shelves, and by this RFID antennas, you can detect the actual products. Right? So if you go through this store, you know all the items and all the products, and this itself has a lot of business use cases. You can identify what are the space items, and also you can provide indoor navigations. So on top of this, we can build a lot of applications. As I mentioned before, we have this RFID. I mean, this is a typical department store. This one store. In a department store, you have so many of these kind of small stores. And we have this VLE beacons. It's being very popularized these days. It's also called Bluetooth Low Energy and also Bluetooth Smart. And basically, we are talking about the same thing. We are using this for different things. One is to provide indoor navigation capabilities because GPS and effective technology within indoors. So you need to have some other mechanism, and the BLE proved to be very handy in that. I only talked about a couple of sensors. There are so many sensors. I will be talking about few of them later on. Now we have the sensors, right? Now the next part is making sense. Now by using these sensors, you can get a lot of data. Data is useless if you are not making sense out of it. Right? The next part is about, okay, now you have this data. Now you have to convert that data into information. But before that, you need to have some connection mechanism, right? So how do you capture this data in maybe a department store, maybe in a website, but you have to take that data, reliably transport into a place where you can process it. Okay, as I mentioned, like we were dealing with the largest department stores in the US. So we are talking about maybe 40-50 millions of users. So it means a lot of data, right? You cannot have this one single server and then one backend server and okay, happily the data comes. So it's going to be a huge task, right? So you definitely need some reliable distributed computing platform. So when it comes to connectivity and communication in this context, very good. So these days I think MQTT is very popular. A lot of IoT platforms. I mean, if you are into IoT, then you know like these are the kind of protocols we are using. If you take IBM Watson IoT platform or Microsoft Azure, or even like your own IoT platform. So one of the very popular technology would be MQTT. And then there is this another protocol. I think it's very obvious. There is a product called Mosquito. So Mosquito is a kind of server. Kind of we call in technical terms broker. So you have this MQTT. This particular server understands MQTT. And then we have this 9.5. Some people call it EP 9.5, whatever. So this is for data integration. Right? You have this data coming from different sources. It can be a physical store, or it can be website. Right? You have to take this data into a central place in order to process them. Otherwise, you will have to process them separately. Okay, you only take website data and you process it, and then you will use only the physical store sensing information and you process it. of course, you can do it, but then you are missing the complete picture. Right? So there can be customers, maybe they are doing some work in the website, and then they do something on the the physical store. Right? So you have to capture this entire thing. So if you are to do that, then you have to take all this data into one single. So that is where this software like Live is very usable. So you can have create data flows and do a little bit of integrations and transformations or kind of things. It's very easy. Okay? And then we have this special again distributed software called Kafka. That is again very popular these days, especially in big data world. The role of Kafka is decouple different, basically decouple the sources, data sources from the actual users. Right? So in a typical, web development world, right? It's all this information is coupled. Like if you are typing something and it goes to this middle layer, and middle layer, so you can only do like a database calls. It's very coupled. But here you are sometimes sensing the data even without knowing the actual usage of it. Right? So a lot of time we just collect data. And then you look at the data, okay, this data is available. And you think, okay, maybe we can apply this algorithm and get something out of it. Right? So you have to just decouple this entire thing. So Kafka is a very good solution for that. It's in technical terms, it's called a pub/sub server, publisher, subscriber. So anybody can send the data to Kafka cluster without knowing who is going to use it. And anybody can get to topics, speak of, and start using it. Right? So it's like our nervous system, of course, without the brain. Like even we have these organs and sensors all around our body, but connecting them, we have this our nervous system. Right? So it's like that. And then the most important thing of making sense, especially in big data world, it's about data processing, all kind of data processing. So I have only listed few products, right? But there are so many products than this, but if I quickly go through them, like we need some scalable storage because, as I mentioned, we are collecting a lot of data. So there should be some scalable storage where we can store this data. Right? So the first thing is DFS, that is Hadoop distributed file system. Basically storing raw files in a distributed. And then we have this Cassandra. It's very popular these days because probably you have learned in your computer science, those who have followed some computer science course, that when it comes to data structures. Right? So in a data structure, sometimes you can only optimize the reads. Right? When you optimize the read, you have to make some sacrifices on the writing aspect. If you optimize your data structure for write, then chances are that you have to make some sacrifice. Distributed world address, they have right from the beginning, they are trying to optimize both. Like they were like thinking entirely differently to achieve this objective, and they kind of achieved that. Because when it comes to read, optimize and write optimized solutions, Cassandra is the kind of solution you want to go. And then we do a lot of batch processing. If you are familiar, if you have heard the word like MapReduce, it's a very popular way of processing large amount of data. And for that, of course, the data will be stored in HDFS and all, but there are nice MapReduce frameworks. So I have only listed few like scaling, cascading. The next one is Hive, and of course, so it's a big, so it's big. Now scaling and cascading, they are pretty much the same thing. The scaling is built on top of cascading. You can The only difference is scaling, you can write the MapReduce jobs by using Scala. So in this big data work, of course you can use languages like Java and quite a few other languages, but in the community, the Scala language is very popular because due to obvious reasons that it's very easy to write MapReduce jobs by using Scala. So I mean, if you are looking for hints, or if you want to get into this all big data, again, I think this is something you have to keep in mind. Scala, then Scala. Okay. And then the batch processing, and then we have this real-time processing. So as the data arrives, you do some processing. Right? So they are also like Kafka, I already talked before. And then we have this Spark. Should I intentionally put this Spark in between the batch processing and real-time processing, because Spark itself is a batch processing software. But what happened is there are some extensions to Spark, like Spark Streaming, which is a real-time processing, has real-time processing capability. And the real-time processing product in this big data ecosystem is called Storm. So take each and every data item coming out of the sources and you start processing. So, but when it comes to Spark streaming, so it's kind of a micro batch we call. It is a kind of real time, but still a batch processing. You take a batch of data items and then you process, right? So if you need like sub-second, response times, you have to go with a solution like Storm. But if you can live with like couple of seconds, then even Spark streaming would do. Right? So those are the kind of evaluations you have to do depending on your requirements. And then I have finally this caching and searching solutions. I put HBase there, but HBase is kind of a scalable storage as well. But the idea is now you have this raw data in HDFS and you run your MapReducing jobs by using maybe say scaling. You finally come up with your final the process intelligent information. And that information you go to store it somewhere, right? It is let's say fast access. So for that you might be using something like HBase or a distributed caching system like Redis. And then we have these nice products, Elasticsearch and Apache Solr. So these two products are very special because underneath they have the same search engine, Apache the same. But Solr is the old guy and Elasticsearch is the new guy. So personally, my preference is Elasticsearch because it has some few advantage over Apache Solr, but I don't want to argue with that. So if you are a Solr guy, okay, you are doing good. So this is the thing, right? Now you have this sensing data, and you have this reliable, communication mechanism. Taking this to your entire big data, processing cluster, and you use one of these. I mean, combination of these solutions. Of course, there are some others, but you pick combination of these and you process it. So this is just the platform, right? So when I say processing, I intentionally about processing, but there are all kind of processings you can do with this data. So there also I will list down few technologies. The first one is Apache Mahout. It has a lot of machine learning algorithms built in. You can use it. And then we have this H2O.ai. It's very popular these days, especially because there is this hype about deep learning and all. And this particular software has these deep learning algorithms, so you can use it. And then if you are familiar with Python and all, then we have scikit-learn. It's very popular package again. And then if you are more into statistical analysis and that kind of processing. We have this R. It has a lot of packages and not just statistics. And even most of the machine learning algorithms are implemented in R. And then we have the lower row. I have put few NLP frameworks. On the far right, we have Gate. It's a UK, UK university, and they actually implemented this entire thing. It's general architecture for text engineering. So they have this entire thing, starting from UI to the processing capabilities, cost tagging. I mean, you name it, everything is there. And we have this open source project called NLP, Open NLP. And on far left, we have this Stanford NLP framework. It's very popular. So all of these, NLP, if you want to do cost tagging, if you want to do anything, so those algorithms are like implemented. But of course, you have to learn those algorithms, like how these algorithms, like internals of algorithms, because there are a lot of parameters as well when you are using these algorithms. That's where your knowledge about NLP and, as Dr. Wan mentioned, all these internal knowledge helps you. Otherwise, if you start trying to blindly use it, you will get some results, but you don't know why. Right? So you have to learn about these theories and all. Then only you can fine tune these software. So that is the the making sense part. So I didn't go into detail because I don't have that much time anyway. So now what now I will do, okay, what kind of conscious actions that we can take? You sense the data and then you successfully transform that data into your big data cluster, and you use all kind of servers to process that data and algorithms to process that data. So what are the informed actions you can take out? So one category is this recommendation. It's very popular. And if you go into any these websites like Amazon, eBay, or any department store website, you see these recommendations. So I have something on that image. A customer who bought this item also bought. So on the left hand side, I have short forms. I have listed down some of the very popular recommendation algorithms. Right? View. So it's like customers who view also view kind of recommendations. Then view both. Customers who view this item ultimately go and vote. Okay, these are the products, right? That kind of recommendation. So then we have vote for. It's actually the same one shown in that image. Customers who bought this item, okay, also bought these items, right? So that kind of recommendation. And there are quite a few based on recently viewed. So you are browsing your website, let's say Amazon. So you are going through a couple of products, and by looking at that browsing patterns also, so you can give some recommendations to the customer. Right? And then we have this interesting recommendation for cart abandonments. Like you browse, you add it to the cart, but you are not going to pay and buy it. But the big brother remembers that. So what it does is maybe 1 week later, you will get an email. Hey, you were looking at these products, and you know what? There is a 10% discount. Are you willing to buy it? Right? So that kind of recommendation. So the same thing is browser amendments. Like you are not even going to whether to add to cart, but you just browse it and just close the browser and go maybe browse Facebook. But again, the big brother remembers and say, okay, you have looked at these products. Guess what? Now we have 50% discount. Would you like to buy? So that kind of recommendations you can give. And I put personalize within brackets, because sometimes you personalize these recommendations. Let's say by looking at given users, maybe browsing patterns. You can say, okay, this guy is always looking at certain brands. And he is always looking at Nike products. Right? So when you are giving these recommendations, what you can do is you can do some boosting to these recommendations. So the first few items will be Nike brand. Right? So that way you can improve these recommendations. And it's not just the brand, like you can see the colors and all sort of attributes by simply looking at users browsing behaviors and their buying patterns. So you can make your recommendations more and more personalized. So then we have all kind of applications specially designed at stores. So I will say like the first one is kiosk hardware sensors. Actually, we actually build that product on the right-hand top corner. You see this white kind of product. That hardware device actually we build it. It has a touch screen and it has RFID sensors, barcode sensors, DLD and proximity sensors and all. So the idea is like if you go towards it, it can automatically detect what are the items with you, and without user doing anything, you can give details about the product. Also give some recommendations. Right? Okay, you have already have this item with you, so why don't you look at this? Right? And we have actually implemented different variations of this product because ultimately it's running a normal OS and normal machine, so you can deploy normal applications to it. So one thing we did was interactive speech support. Actually, we use certain speech recognition SDK. So then it's going to be a normal NLP problem. Right? So so they also like we did a lot of research on let's say experiments on using NLP, because the thing is especially when it comes to search, you can't really use the existing Cobras and all because they were like built by using proper sentences. So, but the kind of language you are encountering in this kind of search are like just a couple of words. Right? You don't have this complete grammatically correct sentence. Right? So for that, what we did was like we were looking at, because as I mentioned, like we have all these tracking capabilities. So what we did was like we were looking at all the search tabs that customers were using. For our benefit, we have millions of records in our disposal, and we actually custom build a corpus. Of course, it's not a easy way to do it because you have to manually do this post tagging and everything. We have to do manually, and we try to get some accuracy improvements over using the normal program. And then this product set conversational. It's actually now if you try to support these conversations in general, of course it's going to be a very difficult project. But what we did was like especially in department stores, there are special dedicated areas for specific products. So there is one product, it's in pilot right now. What we did was we implement this kind of software board for finding baby strollers. So there is this area, it has only baby strollers, and we have this device near that one. Because there the problem is very easy, because you only need to get the user's input about few attributes. Whether you need a car seat, how many babies you want to accommodate. Likewise, there was only like 5-6 questions. Then we were able to narrow down, the most suitable products in the kiosk itself. And of course, then we have this indoor navigation capabilities, as I mentioned before, from DLD, beacons and all. You can say, okay, now you are here. Of course, it is easier because it's in front of the kiosk. And from here, okay, this is the get that product. Right? So we can provide all those things. Now, from the implementation side, we have actually used something called Write script. It's very similar to AIML. It's again the language for interactive bots. And we also use IBM Works and dialogue service. You can implement this kind of conversations. It's again XML format. Uh, I mean, all of these have the same format. Most probably, time it's rule based and we look for ability expressions and all. But in our case, because you are only focusing on a small business area, you can easily do it, right? And then we have this all kind of smart displays. Now, on the right hand side, we have this mannequin with wearing a sari. Actually, we are using something called projection mapping. If you have one projector, you can do this. Actually, that the mannequin is wearing a white sari. So you can actually project different patterns and all into the sari. So you can see like areas, different saris. So the business application we were trying to solve there is not just we have also developed this smart hanger, right? Hanger. So we put a gyroscope and really we can there. So the moment a use case, we can detect. Right? We have the sensors, we can detect. And here we automatically project that dress into the mannequin, the mannequin. Right? So technically, it's not a that hard implementation. You can do it. So that is that. And then we have this customer greeter, and the bottom one. It's again a large display, huge display. Now there are places like only few customers can go at once, right? So what we can do is, now these customers have privileged cards, which is RFID enabled. So when the customer goes near that location, actually you can detect who is this customer, and now in the big data cluster you have pretty much everything about that customer. What are the browsing patterns, their likes and dislikes. So we can provide recommendations into this display. Because we are not saying, hey John, these are the recommendations for you. Of course there is a privacy issue, right? But but we are not saying that. We just randomly show these products. The customer here doesn't know about, okay, these are like showing by looking at my browsing patterns. Already knows this, okay, I'm like just like walking near that one. Suddenly, okay, all my favorite things are displayed. Right? That's the experience. It's a kind of a psychological thing. Yeah? The moment you enter the physical store, based on the things you have browsed in your website, giving these little things. Okay, this product is in the store. Why don't you go and try it out? Right? Glass displays. Especially we tried a glass display by a company called Colombo. Actually on this top left one. I don't know if you can clearly see the glass. Things in science fiction and all these movies, but actually this is a real one. The different boxes you can see, actually it's running a normal website. Right? It's not rocket science. It's just a website. Again, the same concept, right? You can detect the customer, and you can show here in this use case we were showing all the social media, buzz about that, about bunch of products that customer likes. Right? So that is the use case here, of course, but here you can use it for anything. Right? So once you detect the customer, you can show recommendations, you can do anything. And also we have this heads-up displays. This one is a Ixon one, but we use something else. We initially started using Google Glass, but you know what happened to Google Glass, right? But we ended up using some other thing. But this is mainly for store associates. Like they have this issue, like they can't find the items. The customer comes to you and say, okay, where can I find a black dress? So they have no idea, right? So all they have to do is, this is like attached to a mobile device. They can search the product and just press a button. Okay, take me to that product. So because remember, like in the previous case, by using our Colombo, we have mapped everything, all the RFIDs and all the IDs and all. So we can actually give it the shortest path to that product. So this is another. I mean, all of these are in pilot right now. The good thing is, of course, these kind of things you cannot put it into every store at once. Fortunately, in US, there are places that they are ready to this kind of, especially in Mountain View, California. So a lot of tech companies are there. So you can actually pilot these. So that's what we are doing these days. Yeah, that's all. Actually, I just want to, finally say a few things, like, because you don't want to always like take one system and make it super intelligent. Right? So just like maybe individual component is not that intelligent, but you can build an entire system intelligent by carefully and intelligently connecting all those. Right? The end result would be for the normal customer or the user, it looks intelligent. Right? So especially like the people who are coming from the engineering, software engineering backgrounds, usually miss that part. Right? So you have to don't go deep into the technicalities. Always try to see this big picture, the business side of it. Then you can link all these systems nicely. Right? And of course, in this case, our marketing department was very happy. Right? Because this gives a nice story to them, right? So if you go and talk to execs and all about big data, Hadoop and all, imagine what will happen, right? But now you go and talk about, okay, hello CEO, now we are going to make our entire system like intelligent, right? Can make it feel the customers, you know. So if you can talk like that, probably the CEO would understand it. So so that's all I have to manage. So it was somehow related to AI. But I think during the final discussion, if you have any questions.
Thanks, Roshan. But I know we are behind a little bit, but I think we have got some interesting people. And invite the panelists, one, Roshan and Janaka, near to come to front, so we can have we can take a few questions, because one of the objectives of having this session is so that you can. I mean, I know that you must have a lot of questions. Because the customer insights, I think it's a key area that everybody is looking at now. One talks about language processing, which again is an important area, and on top of that we have Udita, we have Menaka, we have Subha, who are working on this thing, and those are the people that I know, but I'm sure that there are others who work on it. So we have got a panel here, and there are a lot of things happening in the AI world, and it's becoming mainstream. So, does anybody have any question? that you would like to ask the panel? Okay. It's okay.
First was, if you want to come, how big should be, how much do you need, and I think that only thing I say is to refer back to more data is better data. But so we use for single corpus of 10 million words. The very first English corpus was 1 million words. So we are 10 times, but that's like hardly enough. English corpus, Google, they release a billion corpus, the corpus. And you see that's a much better. But I think so for English, there's no shortage. So there are lots of 100 million of Tamil, yeah, we struggling a bit, but I think now you can collect 10 million words really easily.
So I'm in charge of the Java practice here. So we do have to do a number of natural language processing and deep projects. For example, I think we discussed a lot about empowering customers. So we'll look at a little bit of the spectrum. If you imagine, I think everybody here came through this construction site, right? I mean, now, for example, we have one of our clients, what we are doing is like just putting all these nice pieces and puzzle together. Like, for example, if you take a pitch out there, right? Everybody has a etc. So, what we are trying to do is, for example, if you have a wearable construction worker can wear. So, and then you monitor the amount of movement and the body, for example. So then we have the ability to predict the probability of making a false move coming in an accident. So we are for a client we are actually doing those into actually that predictability. We are also doing something similar, but again another spin to that. We know most of the people when we grow old, we become a little bit grumpy. That's normal, right? So the thing is, one thing they want to so you can uh, NLP. One of the problems we can fix for some bank clients we have over here would be like, for example, Sri Lanka works a lot on checks. Like we haven't moved into the what you call online processing piece like of transactions yet. So this problem most of the banks have is processing checks because it's a lot of turnover. You can take a little bit of the manual processing off by, for example, you have the magnetic ink, which denotes the account from a bank itself.
be done, right? So it's kind of saying that it's true. The problem is I want to go and use the data as the most complex AI for other technology to that question. So we just want to make sure what is the simplest technique or solution that you can use to solve that uh, problem. As software engineer, students. Uh, because if we can, these technologies are fast, you can't afford to discard all the other things. You still have to learn what neural networks and what are the issues. And you realize, okay, in this kind of situation, I pick deep learning. Like say with NLP, right? You have certain systems you can actually solve simply by using some listed search engine like Solar or Elasticsearch. You have this huge indexing capability. Uh, you can actually solve large portion of problems. Then you need these special scenarios, and you need to using keyword search or anything. It's not enough. Then you go and go some better. Of course, this is an going from a software engineer, but it can be different. Like, who you are, like you might have a different viewpoint.
Just like another saying, Cruz Mr. is everything looks like a nail. So that's why some
the people our own program our own training algorithm. And one of the assignments was natural language, which can be used by just by drawing numbers. What happened was we built the network, and we, of course, we built among our colleagues so that everybody would train the network. They would have separate networks, the numbers and the operations like multiplication, division, subtraction, and addition. So, some was given a the normalization and everything, and I was with the network operation, multiplication and everything. So, what happened was, started training. Well, they got trained very well. The network became very, I think I mean, I can't say that. So, but then after it would identify all the four symbols perfectly. A cross would be multiplication, a slash would be a division, a plus and minus, right? It would understand that. So then afterwards, I was just looking at something on when I looked at the way it has been. So something this is like it maybe just two things. Something that we take for granted, right? So for us, the way the network has trained was it was not looking at the symbol. It was looking at it was the input into 9 quadrants, and it was just where the endings were. So, but this is something we take granted as humans, right? We don't look at it as a plus or a minus. We just look at what happens because the center is always there for us. The first thing we realized was, wow, no, recognizing the things that we take on, and the second one is like, okay, I mean, security that we have how you train it. Yeah.
It also could have been incidents like that the training was done
Exactly.
in a small village.
So, about 2 years back, I was looking for BMW, a project on BMW, and we were talking with all this separate telemetry division where you have Indians who are working on telemetry stuff. We are talking to one of the guys about problems they're having. One guy is a very nice example that somehow started. So what happens is testers they get to take the cars home. So if you look at the being developed, it looks nice outside in BMW. Inside, you only have one seat, which is the racing seat, which has this what you call seat, but and a fire extinguisher and a laptop. Because the car is being tested. Because the moment goes wrong, they are asked to bail out and leave the car and go. So it looks horrible inside, but outside it looks nice. So these guys go, they are supposed to test. One day in winter, he took the home, and like most of this Germany, you have this what do you call this solid in one, not like this but this roller shutter we have. So it's just one solid door that goes up. So he said he rolled up to the garage and he the moment right? So the air conditioning is controlled by the out. It just measures the outside temperature and inside temperature and it adjusts accordingly. So the moment the garage door opened, there was warm air that was in, because inside the garage that came and hit the radiator, the temperature. So the moment the temperature becomes but the car is outside. Now I have to start cooling the cabinet needs to be because yes, the turn on the
when it comes to testing, is the what are the
Yes, okay. I think, would you say you're testing a Q&A system or?
basically a Q&A, like, let's say the AI is on text analysis or something like that. Like when we get the results from the system using NLP, how do you test it? Like what are the usual methods you use for testing? with the multi-seat.
Yeah, I think I don't know you can. So there are some things that are easy to test. For instance, I know what I'm saying, and so I know what should be recognized. So you can 100% test that the speech recognizer is accurate, or I know what are the names in my document, and you can see whether my named entity recognizer is recognizing them 100%. But if you take something like Q&A, one thing is that this goes through many processes, and so you may not know exactly what went wrong when it went wrong. And the other thing is the world is not closed then. No? So you have issues like because there's no closure. Like say you all the Turing test competitors do is to act like a human. They don't want to act better than a human. I mean, like say, so if you say, what is the cube root of 81.3562 or something, they can give the answer like that, but they won't do that. They will say, I'm not good at maths or something like that. In humans, rather than trying to do their best. So most NLP systems that we run are things that try to do their best because they're trying to approximate humans. So Q&A is a particularly hard thing to evaluate in terms of accuracy, in terms of quantitative numbers. But what the output should be, then there's a way of calculating a percentage and precision, recall, sensitivity, specificity. These are the kind of common things, and area under the curve. I mean, there are some very, very specific measurements for these.
So, is the Turing test still accepted for the scientific?
If you want to mimic a human, yeah. So it depends whether you are trying to mimic a human, which is more like cognitive modeling of the human, or whether you want to make a there's a book it doesn't have model of that. Will use P a lot in that I don't know.
We are running a little bit late. One more question. Anybody else has a question? No. Then a couple of announcements. The SLI is a national association. So if you would like to get the membership, please visit the website and become a member, because we do a lot of activities promoting AI. We go to schools, we go to universities, and try to promote AI. And you can. The other one is our up in December 14th, and paper submissions are accepted now until mid-September. September what, Subha? September 15th. If you have a research paper on AI, you can submit it again at the website. We have given details, the submission details. If you have research paper, do submit, because we to promote whatever AI research that is happening in Sri Lanka. These things will be published and will go on our website. That is that, and then let's give a big hand to our panelists, Ruan, Janak, and Rashan, for this thing. And our next meetup will happen in November, so keep reading our website as well as the meetup site for more information. And thank you very much for being here.
One more thing to conclude with today's activities. On behalf give the tokens of appreciation to come side to Dr. Vanita Singh. Janaka Pitering.
Quick announcement. There's a competition like that's organized. It's called John Hughes X. They're having a small meetup on the 20th of this month, July, at the Cinnamon Lakeside. It's at 7 degrees at 5 p.m. We'll give you more information at that point. But if anyone is interested in exploring new business models, things in AI, things that are cutting edge, and we don't need to tell you all about it. Where the business guys will help you all with trying to find out how it applies to business. We'll be happy to see you all there and learn more about it. So it's on the 20th of July at Cinnamon Lakeside, and we're online at johnhughesx.com. And thanks, Virtuous, as well, for accommodating this. So hope to see some great ideas.